Yeah, so I'm using my laptop because my eyes stuck in the screen and it looks weird. So it kind of looks like a alien virus affecting my screen stuff. So it's my talk. Obviously, about Postgis. So I work for CrowdFiber. The best way to describe our product is we get marketing and engineering departments for fiber co-ops and internet providers to talk to each other. The basic gist is they want to build out their infrastructure to more areas, and so they use our product to figure out where to build out to. So our the bread and butter of our product is PostGis. We use PostGis for everything. We store data in it, we do reporting with it, and our just for fun, we use Ruby to talk to it. We're doing Rails. So we serve a bunch of data with it, and I think our peak, when I last looked at like our peak, was like 10 million requests per month, which is a good bit. So why this talk? It's not typo. So I mostly want to address mistakes that most people make with PostGis, like I've made, that I've seen other people make. And I've noticed that some people like do way too much work they shouldn't do. Like they may pull data out of PostGis and then do work on QGIS, which is okay, but you can. There's a lot of things you can do with just basically a database query, and it takes like 5 seconds. Where like you pull it in QGIS, you can't find this button. And there's all kinds of whatever, and 10 minutes later you still haven't figured out what to do. Let's say here, I didn't know Postgis could do that all the time. Even today. Heard that from work, our work side. So the most common issues that I've seen personally, not using spatial indexes, is the biggest issue that I see. People like go ahead and create their schema and they forget to add that index. Confusion with Postgis data types, important reference systems, but the second part is common in general. Everybody screws up projections all the time. And kind of referencing my previous slide, not taking advantage of Postgres or PostGis for the functionality. I was at a talk last week where the guy described Postgres as the Emacs of databases. So if you know what Emacs is, it's this thing, it's this text editor that does everything. And Postgres is kind of this database that does everything. Not only do we have PostGis, but there's also PG routing, which can help you do routing, and there's also it acts as a document database. You've probably heard of MongoDB. Postgres can do that too, and myriad of other things. So I want to try my best to address these issues today. It's looking at foggy from this weekend, so I'm going to do my best. So I want to talk about indexes first. My general philosophy, and I'm going to kind of contradict myself a little later, but my general philosophy is don't index everything. Dang it. Only index what you need. So when you index things in a database, you're sort of fighting these two things. The more indexes you add, the slower it is to write data. So you have to be very careful about how much you actually index. So if you index everything, your reads might be really fast, but your writes will be extremely slow. And you kind of figure out where you should apply indexes. In Postgres and many other database systems, there's this thing called explain analyze, where it explains like what's going on with your query and like whether it used an index or didn't use an index, and how long it took, and some other metrics. But with spatial indexes, shouldn't you index your geometry columns? In my opinion, you should index all of them. So one thing I've noticed with import tools, you may have heard, if you've used Postgres to import or any other tools to import data, most part ones are shaped to PG SQL, ogre to ogre, and another one you might use FME at all. So I think on the writer it has the option to include indexes, but I can't actually remember I know for sure FME has the option, but I can't remember of these two, like which one automatically creates indexes. But regardless of whether or not they do, if you use these tools, you should just always check. Once your tables get to several thousand rows, you'll begin to notice like degradation in performance. I took two queries. Ones that they both use the same data, but one set of tables has indexes on the geometry columns and one doesn't. So it might be kind of small, but the basic gist is I have a table of address points, and I want to join that with parcel data. And if you can read that, you can. The performance is 49 milliseconds. So this is with indexes. And this is sort of a visualization of the explain plane I was talking about earlier. So you can see, you might be familiar. Okay, that's sort of right. You might be familiar with SQL or Postgis or at all. Yeah, well, yeah. SQL. Okay. So kind of a performance issue we see with queries is what we don't want to see is this thing called SQL scan. SQL scan means that it had to go through all the rows in the table to do whatever you asked it to do. So in this case, it had to do a sequence scan for the address table, but since we had an index on the, or since it saw like the query could use the index here, it did for the parcel data. So that's why it was solved. So this is without the index. It's the same query, but it took almost 25,000 milliseconds. And here's the query. It's pretty similar, except you can see here it had to do a sequence scan on the parcel table. So that's it's a night and day difference. I had this. It's a different data set, but I had the same problem before, and I thought it'd be a great example to show you guys that having index is really important. So when you add an index, what kind of index you need to add. So for geospatial data, the best one for most people is this thing called generalized search tree, or GIST. It's not just for geospatial data, pretty much any kind of data that overlaps. For most of the time, it's great as long as your index size isn't greater than the available RAM you have. So once that happens, you either need to increase the RAM you have, or there's another kind of index. It's really similar. It's called BRIN, BRA. So I just want to give an example. If you've never seen SQL before, pretty simple. Create index, the name, and the table, and then the type, and then the column name, which in our case is geometry. Next thing I want to talk about are the Postgis data types. So there's two. First one, I'll talk about the geography. The geography type uses geodetic measurement. It's always represented in GeoJSON. Measurement always expects meters, input and output. This is best if you need to do computations over a large area, or just want accuracy because it's your measurements you're using a spiral instead of flat plane. It's also great if you don't know what you're doing. So if you're if you have a problem you need to solve, but you're not as familiar with projections or GS, and you're just sort of you're kind of in your head, you stable, figure out like what what type of name to use. Geometry, you can't go wrong with it, so just use it. The downside is certain PostGIS functions do not work with it, so you have to convert that to geometry, which is our next thing. Uses Cartesian measurement instead of geodetic. Use whatever SRS you want. Runs the gamut, so plane, whatever, you can use whatever. If you mess up, it's a fault. You use whatever PostGIS function you want. But if you do wind up using the wrong, if you think you're wrong using the wrong SRS, you can always change it. Change permanently in your table. This function called update GeoJSON. Have an example there. Read it. And also something I use all the time in my queries, SE transform. You use this or at least I do. Within my queries, it changes projections all the time. If you, for whatever reason, you think stores your data in the wrong direction, you can always in your query transform it to whatever else, whatever might be better, and it's no big deal. So if you're working with Postgres table, you don't know what that SRS of your data is, how can I find out? So you have two options. The first, most obvious one is just look at your schema. Usually, if it, I'm going to say if it's, your column almost always has a constraint of the actual, so whether it's polygon, point, multi-polygon, whatever, it's going to have that constraint, as well as the actual, whether it's geography or polygon, or geography or geometry. You can also check using you can use this command directly, STSRID. This will tell you, to give you the actual number. You can take one and check. So the SRS I want to use doesn't exist, but I don't want to use it. So there's this table called spatial refsys that has the following definition. You have your EPSG 436. That's what this the EPSG part is. Its off name. The 4326 is off SRID. The SRID at the top can really be whatever you want as long as it doesn't conflict with if for some reason you wanted to modify EPSG 4326, you couldn't use 4326 if you use something else. This SR text here in this part, proj board text down here refers to this stuff. So you have to, your current system has a proj board coordinate definition and a well-known text representation of the SRS. So you would use those in those last two cells right there. And if, for whatever reason, you usually would know, if you have a shapefile, you might know, but if for whatever reason you looked up, EPSG.io is a pretty good resource. If you have a shapefile with the RJ file, you probably do. There's a program called G.SRS info that you can run. I can't remember which suite of tools it's under, but if you have over and all that stuff installed, you probably have that on your machine. You might be able to read that, but you can. So we have an info, so we can apply it in the output. It's just very simple. So from earlier, we transformed existing geometry into that SRS. Since earlier, kind of go back a little bit. So we use 102.0.0.8 for SRID number. So now we can use that here. So I have no idea what SRS I should use. I want PostGIS to figure out what we need. So there's a secret function that nobody talks about called _SD_ That's SRID. The underscore before it means it's a private function, so it's actually used under the scenes by other functions. But it's really handy to use on its own. So what it does, it tries to pick a UTM zone. If it can't find a good one, or zero graphic, and if that doesn't work, it tries to fall back to a Mercator. It's used underneath the hood by the geometry type for sort of functions like SD buffer. It could actually fail to pick up protection, so if it could just fail. So you have to take that into account too. Like I said, it's private function, so it's not documented very well. You can find some tickets in Postgres or Postgis where they talk about it, but it's not formally documented. So you can also read the source, which is, I guess that counts as documentation, but it's not very good documentation. And this is an example how I use it. And apply 2D transforms on that. So ignore that first there. So you would just use it like you would with SC transform. Instead of using your SRID number here, you would use this underscore SC underscore SRID. So now I'm going to talk. This is kind of like a zoo of PostGIS functions and Postgres functions. So the big thing, and this talk was almost entirely a talk about JSON and GeoJSON, but I kind of figured that was a bad idea. So I just gave it a few slides in the presentation. But it really is a really cool feature in Postgres. So you have two types. You have JSON, JSONB, that allow you to store JSON. JSONB is great because it's indexed. So you can index anything in the JSONB like you would a normal column in Postgres. So whereas JSON, the normal JSON column, you can't really do that. We tend to use JSON a good bit in our application. And because of these two types, there are internal functions that Postgres uses that allow you to build JSON and modify JSON on the fly. So we use GeoJSON a lot. We don't store it as that, but we use Postgres a good bit to actually generate the JSON. It's pretty quick. I don't want to talk about that. So there is an internal function in Postgres that allows you to generate, convert your geometry into GeoJSON. Use SC as GeoJSON. So kind of go back. So this is a point, a table of points. My genome is a point. So this is the output it gave me for the GeoJSON column. So 5-point coordinates. But what if we have a table and we want to display what's in the table as a GeoJSON? Use this bad boy right here. And just kind of jump ahead. If you can't read these, I'll have the slides available online. This is actually this. A couple years ago, I read an article how to take a table of geometry and convert them into a single GeoJSON file that you can just basically pop in your query. You could copy and paste the results into like GeoJSON.io and display the result. And this is what this does. I kind of want to give some examples of this. So I grabbed some open data from the city of Chattanooga. I have the parcel data. And let's say I want to grab all the parcels that are assigned to Market Street and display that as GeoJSON. So my query turns into this. Added my little special filters for the city, Chattanooga, type suffix, street name, market. And then up here, have our properties. So GID property, mass names property, in the city. And then doesn't it doesn't have a state column for Chattanooga, but hopefully it's in Tennessee. This is the output. So that generates a GeoJSON I could copy from my Postgres results and paste it into GeoJSON.io and display that. The other thing we use a lot is ST Simplify. It's your run-of-the-mill Rammer Douglas picture settings for that simplification algorithm, and you can do that straight in Postgis. So this is West Tennessee unsimplified, and this is West Tennessee over simplified. So one thing, and another thing that I've run into, I actually ran into this today at work while I was here. There's a neat feature in Postgis you can use to convert a polygon into an outline and a closed outline. And a closed outline, you convert that to a polygon. And we actually use this a lot. This came today while I was in the conference. So we had a guy that gave us a boundary that should have been a polygon, but instead of a polygon, it's a closed line string. So hey, can you fix this for me? And I was like, yeah. We really want to talk about this on my talk. So I decided to insert this in the presentation because it really happened at this point. But the funny thing about that is the client, a bunch of their line strings weren't closed. So if the estimate polygon will not work if your line string is not fully closed. And I was also reading on Stack Overflow, there's this weird issue where if the beginning and the end of the well-known binary isn't the same, even though it might be the same, it won't be considered closed. So this is sort of a way of figuring it out. But this is actually a similar query I ran this morning to fix, or during lunch to fix most of those issues. So just update, we have our table, set our geo to estimate polygon, and then geo again, and our constraint. So in this case, it's my pretend table, and I use 1, but it will take my line, outline to SC, convert it into polygon. So here's an example of these functions running. It's make a polygon, it took the whole line and converted it to a polygon. So there's this other function that is not talked about a lot that we use sometimes. It's great for taking a huge geometry and splitting it into really small ones so that it's easier to store a query. Generally, it's quicker to query on lots of rows rather than one row with a huge geometry. So this is a case where you might use this ST subdivide function to split up your geometry in a bunch of little ones. And the second argument here, max vertices, basically when it's splitting up the geometry, once it hits for whatever one it's working on, once it hits 306, it kind of throws it out to the bucket to be included in the set of items that are split. So these little shapes here should have vertices no more than 256 vertices. So I want to kind of do a fun example inside Postgis. Let's say I want to figure out how many Subway restaurants are in Chattanooga. So I took the business rest data from Chattanooga, and I was kind of curious. So how many Subways are there in Chattanooga? There's 31. It's a lot of Subways. There's a reason for that. There's like a 15. It's super cheap to start one up. So that's why you see more cuts. So that's when there's like 31 actually. So just for fun, I want to see like what area that covered. and I want to do something other than like show the points. So we use something like convex hull to kind of show like the boundary that of the area that the points cover. So this SE convex hull. We use this other function called SE collect to kind of aggregate the geometries together. And then we have our standard filter where business ends like subway, C is Chattanooga, and that's what it's like. So if anybody's familiar with Chattanooga, there's like this area down here that is in the city, but there are no subways. It's kind of interesting. Now, so within the aquarium, I want to find the subway so I can get a sandwich. So it's this bad boy right here. So we use SD distance, which is a function built in to calculate the distance between two geometries. And here I am using the geometry for the business, and then this next one right here, that's the location of the Cincinnati Aquarium. So, and this stuff down here, I actually didn't know about this until recently. So this is the less than dash greater than symbol. It's kind of like SD distance, but it's optimized to use, let me try to explain this right, to use the indexes and uses k nearest neighbors under the hood to sort of figure out the distance. So that's why, like, you maybe would use the SD distance down here. This has a bunch of optimization applied to it. So, according to this, and one thing to note here too, I didn't take into account uniques, so I just left the uniques in because I didn't care at the time. It says here that the closest subway to me at the aquarium is the City Creek subway across the river, Bridge Road. Which if you're familiar with Chattanooga, that's like something for it. I believe that's all I have. Most people call me, it's kind of strange. A lot of people know me, but they only ever call me by my internet handle, which is, it's in what it's called the Seabreeze still. And you can email me if you have any questions. I'm Sean at Seabreeze.com or Sean at CrowdFiber.com. You can find this presentation at Seabreeze.github.io /FOSS4G, not switch 2008. I guess I'll take some questions. Questions or?
Postgis is one